Hello everyone, here is our first video of the year. First of all, you should have your objective written down before you start. That should be at your station. So please pause the video and copy down the objective and play it when you have your objective written down. This video is going to help you to be able to identify if a table is proportional or not using ratios. And when we say ratios, we're representing those ratios as fractions. First, we're going to do some review of 6th grade work. We are going to talk about unit rates. When you are finding a unit rate, we're going to go over two different ways to do it, both using fractions as ratios. So if we want to find their unit rate using equivalent fractions, you are going to first create a ratio with the given data. So that would look like, for this first one, we have miles and hours. So that would look like making a fraction of miles and hours, 420 over 7. The second step is to create an equivalent fraction with a quantity of 1. So we want this to have an equivalent fraction of 1. Unit means 1. So we want to know in 1 hour how many miles can this situation go. We have our ratio, and we're creating our equivalent fraction. In order to create this equivalent fraction, what happens? How do you get from 7 to 1? Well, you divide by 7. Whatever we do to the bottom, or the denominator, we have to also do to the top. This should look familiar from 6th grade, or at least the idea of finding equivalent fractions. So this tells us that in 60 miles, it takes 1 hour. So that leaves us with the ratio of 60 miles per, meaning 1 per hour. 60 miles in 1 hour. Let's do that again over here with customers and days. We have customers over days. We have 360 in 30 days. So how many in 1 day? We're dividing by 30. Divide by 30 on the top as well to create an equivalent fraction. And we're going to get 12. So that tells us that 12 customers in 1 day, 12 customers per day. This should be review, or at least look familiar. We can do the same thing using a table. We're going to be using a lot of tables this unit. So when we're finding the unit rate using a table, you're first going to create and label a table. Then, in your table, you're going to create a row with 1 in the X column. So this is the same thing we're doing here. We're creating a new ratio with 1 the same way we did here. So for our first one, we create a table, and we're going to label X and Y. We're also going to label what the units for X and Y are. X is going to be seconds. Y is going to be meters. These switch. So we have 16 seconds, 40 meters. We want to know in 1 second how far can this situation go. We see that we're dividing by 16, and we're also going to divide by 16 here. It's the same concept as equivalent fractions, it's just written in a different format. This is something you're going to want to use your calculator for. If you don't have your calculator, go ahead and pause the video and get it out now. We have 40 divided by 16, which gives us 2.5 or 2 5/10. So this tells us that we can go 2.5 or 2 5/10 meters per 1 second. Go ahead and pause and try this one on your own and unpause when you think you have it. Okay, your table should look like X and Y. Make sure you label those pounds and dollars. You generally, after the 4 is going to be what's in the X column. So we have dollars and pounds. We have 5 pounds for $7.96. How much do we have for 1 pound? Well, we're dividing by 5, so we're also dividing the cost by 5. Again, use your calculator. If the numbers are simple, you should not use your calculator, but for things like this, feel free to use your calculator. So we get $1 and then 592 thousandths. This is not in money units, so we're going to need to round this to the 9, and it's going to stay the same. So we have $1.59 per pound. LB is the abbreviation for pounds. Okay, this should be review. This is going to be a rather long video compared to the rest of the week. And we're moving on to this new concept of, is it proportional? We know that a situation is proportional if the ratios between the quantities are just a different way of saying items or pieces. The ratios between the quantities are all the same. So if every single unit rate is the same, that situation is proportional. So this ratios between the quantities, we know this as the unit rate. A new word we're going to use for this is constant of proportionality. Constant of proportionality. So if the whole situation has the same constant of proportionality, proportionality, again, this is unit rate, just a new word, we can use the, now I'm going to abbreviate it, constant of proportionality for any quantity in the relationship. So if we know it's proportional, then that unit rate can be used for the whole entire situation. So when we are given a table and we are asked if it's proportional, first we need to identify the constant of proportionality, for all quantities. That means for all rows, for all pieces. If the situation is proportional, all the ratios are the same or are equal. If the situation is not proportional, at least one ratio is different. If we have 10 ratios that are the same and one that's different, the situation is still not proportional. So we're going to do 2 examples, and then you're going to try some on your own. So, are the following tables proportional? We're going to go back to our steps right here to determine this. We're going to draw a line just so we're clear about where the work is. This table we're going to do here, this table we're going to do here. So first, identify the constant proportionality or unit rate for all quantities. My ratios are all going to be in miles over hours. And I'm going to use all 3 of these. So I have 0 over 0, which looks funny. I have 16 over 4, and I have 400 over 100. This one is, officially it's called undefined, but it really is not, does not work in, it does not give us a number in this situation. So we're going to ignore this for now. This is equal to 4, and this is equal to 4. Now if I look over at my table, I notice that this 4 shows up here. 100 times 4 gives us 400. 4 times 4 gives us 16. Is 0 times 4 also equal to 0? Yes. So this is indeed proportional. Now this second one, we have dollars over hours. Is this proportional? Let's see. We have 9 over 3, 16 over 4, and 25 over 5. 9 divided by 3 is 3. 16 divided by 4 is 4. Already, is this proportional? No, because these are different. And this is equal to 5. So no, not proportional, because the constant of proportionality, and I'm going to abbreviate that, are different. Okay, there are 3 problems for you to do on your own about frozen yogurt, about Alex's summer business, and then determining if these 2 tables are proportional. Number 4 is optional. If you finish early, it will be extra credit if you would like to do it at home, even if you don't have time in class. When you're finished, you can start your exit ticket if it's available. Awesome. Have a great time.